So now I want to walk through a very simplistic example of how selection bias can affect your measures of association. So here are some made up data where we have no selection bias occurring. So you have your target population and you have those with the disease and those with the exposure. Now, once again, just as a side note, we always sample from our population to create our study group or our study population. Typically, it's not possible to study every single person in our population at risk or of interest, so we sample from them. So in this particular example, we're choosing to sample 50% roughly of all the particular factors of our disease and are exposed, right? So thinking about this in a simplistic way, if you have your 2x2 table and you have, as shown here, we're going to simply sample half of those people, 50-50, by disease and exposure statuses to create our study population. So that's what we get over here with our 2x2 table, and these columns and rows represent the sums. So in our target population, if we have a measure of the prevalence, let's say in this case it's calculated as 10% for the disease, given our sampling weights were equal, the prevalence of disease in our study population is also 10%. Similarly, if the prevalence of the risk factor is calculated, we find it's 20% in our target population. Given the equal weighting, it's also 20% in our study population. And that can be followed on with respect to measures of association, either relative risk or odds ratio, depending on the design of the study. And they are equal because the sampling weights were the same. Okay, that seems pretty obvious. However, you can have selection bias in such that it's either overt or unconsciously done, and that can quickly affect your measures of association. So in this particular example, same data, but instead of it being 50% sampling, it's 50% sampling for the people with disease and who have the exposure, but 100% sampling for all other groups of our 2x2 table. We do have bias sampling in our total numbers of disease, but it doesn't seem to affect our overall measure of prevalence because our prevalence is so low. And as far as the prevalence of the risk factor is concerned, because the overall numbers were so low, even with that imbalanced selection weighting, the prevalence of the risk factors are not too different in the study population sample versus the target population. But where you see the difference occurring is in your measure of association. So in the true population, the relative risk is 2.67. However, after this bias selection approach, it's now 1.5. So there's a reduction in the relative risk. Similarly, there's a reduction in our odds ratio from 3.08 to 1.54. So what this kind of bias has done is it has led us to a lower measure of association than the true measure of association, and that leads us to what's called the bias toward the null. Again, if our null hypothesis is that there's no difference, i.e. the relative risk or the odds ratio is approximately 1, this bias is leading us to get a smaller measure of association. Hence, we're moving toward the null hypothesis, so it's called a bias toward the null. Just as a note, if the values were larger than the true values, then we would have a bias away from the null. Okay, so in summary, bias toward the null is when our measures are smaller than the truth, and a bias away from the null is when our measures from our study are larger than the true measures. So another example of selection bias comes from a cross-sectional study performed where there was what's called non-response bias. This is a bias in people who are selected to participate in a particular study, in this case a survey or cross-sectional study, but the individuals choosing not to respond were different than those who chose to respond. This is in a study population of Sweden, and the research question was, what is the nationwide prevalence of respiratory distress, including asthma and chronic bronchitis? They mailed out 9,132 questionnaires, and they got an 85% response rate, which, by the way, is pretty high for a survey. They contacted the non-respondents, for which there was 15%. And they asked them some questions. And they found that the non-responders were significantly more likely to be current smokers and have more respiratory disease, including wheezing and chronic cough, etc., compared to the responders. So this form of non-response bias was associated with the individuals knowing of their disease status as well as their exposure status. It's also a form of embarrassment sort of bias in that people don't want to report their risk factors. And had the researchers not conducted this telephone interview of the non-respondents, they would have calculated a measure of the prevalence of the disease lower than the true measure. So again, it's just one example of many where there can be selection bias in the individuals who choose or who are chosen to participate in an observational study, as well as an experimental study trial. And it can lead to a measure that's above or below the true measure. So now I want to talk about the different types of information bias. Selection bias is what we just talked about. Frankly, there are many more kinds of information biases than there are selection bias. And that's largely just because of the way information are collected and all the different mishaps that can occur in a study. So this is a list of a few key information biases, but by no means an exhaustive list. The first one I want to talk about is surveillance bias. This is a bias that leads to a difference in the way the disease is being searched or assessed for in one group compared to another. And this could be driven by some knowledge of some other factor, perhaps the exposure, that can again lead to the researchers looking more closely for the disease in one group than the other group. And that, of course, leads to a biased estimate. So along those same lines is what's called diagnostic suspicion bias, and this is when the knowledge of the exposure influences the testing. So the surveillance and the diagnostic are very similar types of biases. You can have also interviewer bias. This is a bias that happens when the person soliciting information from the subjects involved in the trial or the study is somehow biased in how they're collecting the information. It has to do with the way they're asking questions, particularly if they're not asking questions in a systematic way. Again, that can create a bias. There's recall bias. This is a bias that occurs in case control studies. And we've talked about this before. This is a bias when the diseased or the non-diseased groups are going to recall their past exposure differently. The example I've given in this class has to do with birth defects and exposures while a woman was pregnant. And there are repeated examples of recall bias in that type of study because women who have children born with birth defects are more likely to recall their past exposures during pregnancy than those women who had a child without a birth defect. There's also unacceptability bias, and that is what we saw in the example I just gave of the prevalence survey in Sweden. Again, that's a bias that occurs because people, subjects chosen or choose to either not to provide that information, or they provide more information because of their views on whether or not it's considered acceptable. There's a family information bias. This is a bias that happens when members of a study are deceased, and so there are data being solicited from family members. And basically what happens is in the case of, say, a case control study where some of the cases have passed away, the family members of those cases are going to potentially provide more information or different kinds of information about their family members' past exposures before dying than a person would provide who's still living. There's also loss to follow-up or dropout bias, and this is just a bias that occurs when there's discordant or high numbers of persons lost to follow-up during the study, and that leads to missing information that creates a bias in your measure of association. There's mortality bias, and this is a bias which, when there's a discordant number of people who die during the study, that can affect your ability to measure for the disease effectively. This is a kind of bias that occurs in a cohort study. There's also a misclassification bias, and we've talked about this before. This is when we can have differential versus non-differential misclassification, and that can bias your measure of association away or toward the null. The differential type is when there's a different type of information collected in one group. That's different from non-differential bias when there's equal information collected from both groups. However, that information is not collected accurately or adequately, and that can also lead to bias. And then there's what's called response fatigue bias. This occurs in long-term cohort studies where simply individual subjects who participate in the cohort become fatigued by participation and they stop providing accurate information. So here is an example of how bias due to loss to follow-up can affect your measure of association. This is just showing a very simple view of when you have on the left-hand side a full cohort of the subjects involved in the study. And then on the right-hand side, you're seeing where there's some loss to follow-up data in those in all of your members of your cohort. And in this case, it's simply just illustrating how the relative measure of risk can go down just due to some small loss to follow-up. Here's an example of recall bias, and this goes back to the prenatal infections and congenital malformation scenario. And this is showing you, these are from true data of a recall bias effect in that case control study. If we know among the cases and the controls that the true infection rate in both is about 15%, however, in the study itself, the proportion of cases who report the prior infection was 9%, and in the controls was 1.5%. What we're seeing here is both a recall bias, that is more cases than controls are reporting the past infection. However, we're also seeing a bias in terms of the amount that's being reported. That is, the reported amount is less than the true amount. So two types of biases are occurring here. But the main message is that you have this discordance between the infection rates that are being reported, and that's a recall bias.